Today, my name is Mihaela Blenda. First, I'm a program manager on SQL Server team, and together with my colleague, we're going to go and present to you all the solutions that are available with SQL Server 2017 for HADR as well as read scale-out scenarios. Moshed, why don't you introduce yourself as well and talk a little bit about your role with this release that you just announced.
Thank you, Mihaela. So my job is to tell jokes. Well, she's the brain. She's going to do all the talking, and I'm going to just make fun of people, or myself, not people. Sorry. So I work in a group called Customer Advisory Team in Microsoft, where our job is to work with new features or product with customers and then bring back the feedback over to the product team so that we can iterate over the software release cycle and make it better. So anytime, my main involvement in SQL on Linux was to look at the overall picture, but mainly focus on the HA part also, the high availability part. That's all. Go ahead, Mihaela.
Thank you, Moshed. Yep. So now that you know who we are, we'd like to know a little bit about you as well. So just with a simple raise of hands, who is a SQL Server expert in the room and went all the Ignite sessions on SQL Server 2017?
You can raise your hand. It's okay. I mean,
okay.
We won't know.
We're not going to check, I promise. Who is a Linux expert? Okay. Who actually used SQL Server on Linux and tried out?
Has anybody tried it out in here? You have? All right.
Oh,
two hands. Great.
Awesome.
3. Okay.
Who is in this
Sold.
category? You're tricky. Who is in this category? Oh, nice. And finally, who is unique? We're definitely gonna leave some time for you to ask us questions at the end. Thank you. We have a diverse group here. Please feel free to ask questions or clarifications during presentation or during the demos. But we'll definitely leave some time at the end for Q&A if you have some.
So one last question. Who knows about high availability in SQL Server here? Great. Okay.
Okay. Then we're done.
Yeah.
So what are we going to talk about today? I'm going to start with just an overview of the solutions that we have for HADR for SQL Server. And then we're going to deep dive into what is new in this release we just announced. Of course, we're going to talk about the solutions that are available on Linux, but also some additional scenarios around read scale out, very hot topic around cross-platform scenarios now that we have SQL Server running on Linux. And we're going to close with a snapshot of the solutions that we have on the market from third-party vendors that our customers can use to build their HADR systems. We're going to have a few demos in between. So let's get started. So SQL Server 2017, I think it's amazing that we have just a little bit more than a year from our previous release. And now we have a new version available, obviously, on Windows, and for the first time ever on other platforms like Linux and Docker. So now with this release, you can actually run Linux applications on this industry-leading performance database system for all your type of workloads. We do know that SQL Server is the most secure database for years in a row. And on top of being the most secure and reliable software, we also offer you a security toolkit that can enable you to protect your most sensitive data, as well as make sure that you meet all the compliance requirements. One such example is always encrypted, SQL Server being the only RDBMS with client-side encryption built in. Before moving along with the HADR features, I would like to highlight a few other enhancements with 2017. You can build intelligent applications using in-database machine learning with R and new in 2017 with Python support as well. You can query and build relationships within your data by storing and query graph data with the SQL Server 2017. And we also have few enhancements in the performance space with adaptive query processing as well as automatic query tuning. We had a few sessions on all these aspects here at Ignite, so if you didn't see them before, you should go online and go deeper in those cool features. On top of having in-memory on all these workloads, with SQL Server 2017, we also offer a consistent experience across on-premises, on cloud, across all editions as well. We have common tool set for development and manageability, and definitely a common T-SQL surface area. So ultimately, our goal is for you to be able to have a good experience with data, irrespective where you want to implement it. And this applies to HADR features as well. So we want you to be able to achieve a broad range of availability SLAs to meet your business requirements for different scenarios. We use this framing when we talk about the solutions that are available for HADR. With simple HA, you can take advantage of virtualization technologies to achieve a higher degree of resiliency against host-level failures, fault tolerance against hardware failures, as well as elasticity and resource maximization. This system can run not only on premises, but simple HA applies to SQL Server running in cloud, on private or public cloud. It applies to hybrid scenarios or even containerized environment now with support for containers as well.
So hey, Mihaela, are these all available in SQL on Linux today?
Yeah, definitely. You can run SQL Server running on Linux VMs as well, and all the solutions that we're going to talk about here are going to be available are available on Linux as well. Awesome. With the simple DR, we are looking at database backup as the fundamental form of disaster recovery, and most importantly, with data protection. With standard HADR, we are looking at instance level protection with failover cluster instance, or you can have a database level protection with basic availability groups. For DR in this category, once you have your baseline protection with backups, the rest of the environment can be customized depending on your organizational needs. So you can use log shipping or failover clustering for DR purposes as well. And finally, for mission-critical SQL workloads, we have always-on availability groups, which is an integrated solution that will enable you to build redundancy at a database level within or across data centers. And this will enable fast application failover in case of planned or, most importantly, unplanned downtime. So what is new in 2017? Definitely with SQL Server on Linux support, as I was mentioning earlier, we're bringing all these solutions to Linux as well. But this was not the only area that we invested on with SQL 2017. We have some additional scenarios with read scale out that we're enabling with 2017 now that we don't depend necessarily on the cluster infrastructure. We're going to talk later about that. Definitely with multiple platforms that we support SQL Server, where it's going to be very interesting to understand what is supported and what works cross-platform. We have backup restore, we have log shipping working cross-platform, and definitely the most ask questions, we also have availability groups working in a cross-platform configuration as well. Also, with 2017, we closed the gap regarding DTC support with databases that are part of availability groups. And we also added a new option to the availability group configuration with require synchronized secondaries to come in. We're going to go and take each one of these enhancements and go a little bit deeper on them. First, let's consider you are this organization that has an all Linux infrastructure, and you're building this mission-critical application. And now that SQL Server is supported on Linux, you actually consider to use the SQL Server on the new platform. So to enable this scenario, we brought always-on availability groups to Linux as well. So in addition to the main workflow of high availability setup with always-on availability groups working on Linux, we also brought in all the features that make availability groups this integrated, flexible, and cost-efficient capabilities. You have multiple secondaries, replicas, the same number as in Linux. You have automatic monitoring, automatic failover, automatic failure detection, and readable secondaries, automatic seeding, database level monitoring, and so on. So all the enhancements that we added throughout the years, always on availability groups, they're going to be available in Linux as well. All this is done through integrated with native cluster technologies. And I'm bringing up Pacemaker here. And I'm getting a lot of questions, why Pacemaker? So all the OS distros that we support SQL Server on Linux run on support this cluster solution. Actually, the Red Hat's HA add-on as well as SUSE's HA add-on are based on Pacemaker. So this was one of the reasons we went with this cluster technologies, as well as our private preview group of customers that we interacted with. They pointed us to this cluster technology as well.
Has anybody here heard of Pacemaker before today?
In this conference.
Does anybody have a pacemaker in them? No. I do.
So I talked a little bit about what solutions are available on Linux and what are the features that we're enabling. I want to go a level even more down and talk about how we implemented HADR on Linux. We all know that in order to achieve higher availability SLAs, we need a cluster in order to automatically monitor the system, to detect the failures, and orchestrate the failover when necessary. On Windows, we depend on Windows Server Failover Cluster, and we integrate with this cluster solution in order to achieve all the orchestration required from, again, monitoring, failure detection, and failover perspective. On Linux, obviously, we didn't have Windows Server Failover Cluster. So we build this resource agents for Pacemaker, but the way SQL Server and Pacemaker integrates is not the same as in Windows. So while in Windows we have this communication layer between the server and the cluster going both ways, in Linux, only Pacemaker talks to SQL Server, and SQL Server is not what we call cluster aware. So what does it mean? I can give you a simple example. Let's take failover, because it's the most important, right? So while in Windows, you can trigger a failover from both SQL Server. You can use your T-SQL APIs and use alter availability groups failover, and then the cluster will react accordingly. Or you can go to the cluster, right, and trigger a failover through the cluster APIs. In Linux, it's only the cluster who is going to be who's going to orchestrate the availability group. So you can trigger a failover only from the cluster perspective using the cluster manageability tools. If you go to SQL Server and say failover, cluster, so there is no way cluster will be notified about that, so it will not react to the failover command, and you're going to run into a lot of troubles. So we even made it harder for you, so you're actually not going to be available to trigger the failover. Only in certain cases that you will be able to do that. You can, if you want more details, you can go to our documentation and find out that. Another example is getting cluster status, for example. You can go to SQL Server in Windows and find cluster status from the cluster DMVs, right? Similarly, on Linux, you won't be able to do that because SQL cannot query the cluster in this way.
So before you move on from this one, can you talk about a little bit about your what are the limitations on the cross-platform solution that you have there?
Yeah, so we're still working on a few things, and I'm going to go through that. On your question on what cross-platform, there is no cluster solution that SQL Server integrates with that will support the cross-cluster configuration. So we're going to talk about later about the cross-cluster setup for availability, cross-platform setup for availability group, which it works, but that will not give you a high availability system because we're missing the clustering layer. So if you're going to set up an availability group cross-platform, you need to remember that there is no fabric to orchestrate that availability group, so everything has to happen manually from monitoring, failure detection, as well as the only manual failover will be supported.
Yeah, but you can use it for DR purposes, obviously. And when we say cross-platform it between Windows and Linux, just so you guys are clear, it's a technology that's in 2017. It's new and it works awesome. We'll have a demo on this later.
Yes?
Will the 2017 on Windows behave the same way as HADR behave the same way as 2016? So you can get all your cluster information from the DMV?
From Windows perspective, nothing changed. So if your system or your cluster HADR system runs on Windows, we're only going to have some enhancements that I'm going to mention later. And I mentioned earlier the read scale out capabilities and a few other enhancements that we have available on both platforms, actually, on Linux and Windows. But yes, definitely, Windows failover clustering, there is no change to how you know things work there. I would like to bring up two other things. We're still working with our OS vendors to support Pacemaker and their HA add-ons and cloud environments, as well as containerized environments. So that's something that it's still being worked on from Linux support perspective. So now we're going to see all these things in action, actually.
Oh my God, OK. So,
Moshed is going to show us how to set up a 3 nodes availability group, add it as a resource in a Pacemaker cluster, and we're going to try to trigger an automatic failover by stopping SQL Server, I guess, or trying.
All right.
Let's see if, OK.
All right, everybody believes me that these are on Linux? If not,
I guess it's too late now
right
to say that we're lying.
OK. Let's start by creating an availability group here. We're gonna create the availability group through Wizard. People love GUI, or maybe people love GUI, I don't know. Linux people don't. I'm gonna create an external cluster. So this is something new in 2017. You can create an external cluster and a cluster that's equal, without any cluster, so none.
Yeah, so what this design for Pacemaker that we have now in 2017 enabled us to introduce this concept of cluster types. So for anything that is not a Windows Server failover cluster and you do integrate with, we call it external. So it's this outside-in orchestration of the availability group. And we also have a cluster type of none, meaning the availability group is not orchestrated by any cluster solution. So you can actually have it by standalone by itself.
So here I have 3 nodes that I added in an availability group, and I chose synchronous commit so that I can do a automatic failover. One thing to notice, it has the UI now has automatic seeding as a check option here. This was not available in 2016. Next, it's going to do a bunch of checks. And then it's going to start building my availability group. So while it's going on, Mihela, do you want to explain why 3-node cluster?
Yes, yes. So I was saying earlier that in Windows, Windows Server failover cluster plays the role of the distributed metadata storage for availability group metadata. So all the AG metadata is stored in the cluster level. In Linux, because we detached the availability group from this cluster, whatever cluster technology you're going to integrate with, this metadata is kept within SQL Server itself, right? So in order to safely failover, we need to have a quorum of nodes that agree that a specific failover target is suitable for failover. And that is only achieved when you have, of course, 3 nodes, a 3-nodes cluster configuration.
Of course, it failed on one of the nodes right now.
Yeah, let's blame the network. It was, I think, actually, it looks good. Can you refresh?
Yeah.
No?
Okay.
You want to start over, or what you're going to do?
Yeah, let's start over.
Okay, you're brave.
And
You need to clean up the... I think you're not patient. Eventually, it will synchronize.
okay.
Yeah, so if there are, do you have any questions on, yes?
Just wanted to say, so on the Linux side, there's no automatic failover, it's all manual?
There is automatic failover, always automatic failover if you integrate with the cluster. Definitely on Linux, we do enable all the HADR capabilities that you have on Windows. My point was that there might be different means to how you do things, but all features like automatic failover and all the orchestration that the cluster does, you'll have it on Linux as well.
Do you get the 5 different levels of granularity?
Yes. So we use the same public APIs that Windows Server failover cluster uses in order to monitor the health of the system. So we use SP Server Diagnostic to determine the health of the SQL Server instance. We use public T-SQL failover APIs to trigger failover. So it's definitely the same. SP Server Diagnostics is what you're asking about. Yes. Definitely. So on a cross-platform configuration, so when you have replicas both on Windows and on Linux, you will not have automatic failover because there is no cluster to coordinate all this. Yeah, there is another question? Yes, so yes.
That is the big difference.
Yes, on
Windows
Linux, you need to
right
have
now.
a 3-node synchronized cluster, 3 nodes that are availability mode synchronized. With the upcoming release, service update release, we're going to enable an option for a cost-efficient configuration. So one of the replicas will be able to be on Express, meaning that it will play the role of a witness pretty much. So it will only hold the metadata that I was telling you earlier that is stored within SQL Server. It will not have any data, but you will be able to use the Express or any other free edition in order to store that. So not at this time.
Not for Linux right now.
Not
no.
at this time.
Okay. So my always on
you
availability
fixed it.
group is running?
So,
okay.
Yes?
Is there any difference when it comes to configuring the client endpoint between Windows and Linux?
Very good question. So we're going to see it right now. We know that when, on Windows, we have the listener as a resource in the cluster that will enable client application to transparently connect to SQL Server irrespective of which replica is the primary. We have a similar, the equivalent, if you want, on Linux is what we call the virtual IP resource. And we're going to
show you that right now.
Configure it right now.
So I have kind of my cluster set up because I didn't want to do all the pacemaker setup while we are on stage. You can see on when I do PCS status that there are 3 nodes online in this pacemaker setup. Now I'm going to go ahead and add the availability group that I created as a resource and add a virtual IP as a resource also. So to do that, I'm not even going to try to type it. I'll just copy and paste it.
Why?
You know.
Yeah,
I'll make some kind of mistake if I try to type
yeah,
this.
first command is just to create the resource in the cluster, pretty much saying that, you know, the availability group that we created earlier, now it's going to be managed by the cluster.
Okay. Then I added the virtual IP as a resource. This
is what we were mentioning earlier is the equivalent of the listener.
Then I'm adding a collocation constraint. Collocation constraint basically says that master and IP should be on the same node. Let's run that. And then I have to add an ordering constraint on pacemaker, basically saying that do not start my virtual IP before you start my master node or the primary node. So once that's done, you can take a look at PCS status, and hopefully it updated everything. Yep. Now you can see that I have 1 master, 2 slaves, basically 1 primary, 2 secondaries, and the virtual IP has started on rail 1, which is the primary. Okay? Now let's start a failover. So to do that,
do you have an application?
Oh yeah, let's run the application first.
Let's see if you're actually gonna, okay. So you're connected to
it basically
rail 1
is a bash shell that runs SQL CMD and connects to the virtual IP and echoes out at that server name. That's all I'm doing. Right now, rail 1 is primary, so it's echoing out rail 1. Let's stop SQL Server to start an auto failover.
Okay, you're not lucky today.
No, the demo gods are not with us. Okay, SQL Server stopped. Let's see, so CRM on is a command that you can run to actively monitor your cluster. It will actually update and show you what the status of the cluster is. If you don't want to run CRM on, you can obviously go back to PCS status for pacemaker. So here you can see that the rail 1 just failed, or the first machine that was primary failed. And since it's set up to do automatic failover, or we have a cluster behind it, it will automatically fail over to one of the other secondary nodes. And it may take a little while, but trust me, it works.
I want to go back to the question related to the virtual IP there. So what we know that in Windows we have the listener resource, as I was mentioning earlier, and we also, when we do that, configure that listener in Windows, what the cluster does behind the scenes, it also registers the listener IP with the virtual network name, right? This does not exist in Pacemaker. So while you can use this virtual IP resource and it will be managed by the cluster, it will point always to the primary because we added this collocation constraints. You'll have to actually manually register the IP with the server name of your choice within your DNS server so that you get a name instead of connecting to the IP. We tend to remember the names better than the IPs. So the virtual network name equivalent of what we have in Windows does not exist in Pacemaker.
Okay. So if you come back and focus again on the screen, now you can see that Rail 2 has become the primary, Rail 3 is the secondary, and there is no Rail 1 anymore because SQL Server, I stopped SQL Server intentionally on that one, just to show the failover. And if we go back to our monitoring system, interesting.
This is your...
It connected once, then it's failing. It should. Anyway, so let's move on with, Rail 1 failed. Why? Rail 1 failed,
okay,
we knew that already.
You're not. So we did failover.
And yeah, we did automatic failover. And Rail 2 is right now the primary. And if I start SQL Server on the previous primary, which is Rail 1, it's going to come back and join this cluster automatically and update the data. And you can see on here, if I, Rail 2, if I do a refresh, now this is the primary. Can you guys see that? I can try using Zoomit, but Zoomit is not cooperating with me today. There.
Something is going wrong with your cluster, definitely.
All right. It hasn't come back up yet. Anyway, move on. Let's move on because we have a lot of more things to cover.
Okay, let's switch back then to...
Okay. Right before we switched, it came back and joined.
It came back? Okay, you want to see?
So you can see that Rail 1 came back and joined as a secondary now.
Okay.
There's a question over there.
Thank you. Yes?
So in this case, you shut down one, but if you shut down another,
No, right? Because it will lose quorum. You need a quorum
of
replica
to
to be able to fail over.
Let's go.
Okay. Now let's look at a few other scenarios that we also enabled with 2017. And we got this question a lot around what is actually supported in a cross-platform configuration. Continuing the scenario game, let's assume that you are this enterprise that is moving to an all Linux infrastructure. You had all Linux system in your configuration. You're keeping Windows systems just to run SQL Server, and now you want to do some consolidation. But due to rigorous business requirements, you need to make sure that the migration from one system to another is done live and with minimum downtime. The solution for this is to build a distributed availability group with a primary availability group on Windows and the secondary availability group on Linux. So this is the fastest way to, first of all, to migrate your data because it's leveraging the same replication technology, right? That is for SQL Server that is supported by availability groups. And also, it will ensure that during this migration, you're protected at all times. Distributed availability, I want to mention two more things about this configuration. You can use distributed AGs to also upgrade your underlying infrastructure. So if you, for example, you have a SQL Server running on Windows 2012, right, one system, and you want to upgrade to Windows 2016, you can configure a distributed availability group, and that's the easiest way to migrate from one older version of Windows to a newer one when SQL Server has the same version. But now, with distributed AGs being available actually on 2 versions of SQL Server, you can use it to upgrade your SQL Server as well. Another cross-platform scenario is when you actually want to not migrate your HA system, but just migrate your SQL Server workload from a standalone perspective to Linux, or from Linux to Windows. It works both ways. You can do this for various purposes. You can do this for DR, you can do this just for the purpose of migration, or just because you want to test your SQL Server workload for certification purposes, for example, on a new platform. In terms of hybrid solutions, so we're talking about not only a cross-platform configuration, but a cross-environment configuration as well. So you can, for a cost-effective, for example, DR solution, you can have your replica in cloud. But I would like to add one note here. While we know that on Windows, you can have an actual Windows Server failover cluster that spawns on-premise and cloud. On Linux, again, because we don't have that cloud support yet, that's not going to be possible. Well, it's not possible yet, right?
So you can use it for DR still, or migration of your data, but don't try to use it for HA if you have a Linux cluster.
Yeah, we don't have the cluster support for HA. So now we're going to go back to you to see if you're, we have more luck now with a cross-platform availability group,
yes,
right?
That's one of my favorite topics of this release. So if you guys, since you guys don't believe me, I had it up and running, and I did an ATAT server, ATAT version on a registered server, and it shows one of them is a Windows server, the other one is a Linux server. Now let's try to create the availability group. Hope this time it'll work. I'll do it through the wizard again. This time I'm going to choose none as my cluster option because I do not have I cannot create a cluster between Windows and Linux. It's exactly. But you can still create an AG for data migration or DR purposes. That's what we are saying. So DB1 is the one that meets prerequisite. We're going to add my Windows connection, and again, automatic seeding. Wanted to point that out. It's on the GUI.
Yeah, so we should, let's stop a little bit there. And we know that automatic seeding requires the same disk layout on all the replicas in order to work, right? This is a Windows and a Linux system. The disk layout definitely and the path will not be the same. Automatic seeding, though, it is supported and it will work as long as from a default path to a default path. So if your databases are on the default path from on Windows and Linux, then seeding will work.
Okay, so since I started with the async availability mode, let's try changing it so that we can do a failover. Because if it's async, you have to do a forced failover. You cannot do a manual failover. And a forced failover will include data loss. I don't want to do that. So I'm going to turn it into a sync commit. Say OK. And then try to do a failover from the secondary node using GUI again. And
yeah, you connect to the primary.
Yep.
Okay.
I'm blaming the network.
Okay.
All right, I'm connected. Let's do a failover. Voila, it's done. So my Linux machine became the secondary, and the Windows machine now is primary.
Again, only manual failover, right? We don't have automatic
Since
failover.
you don't have a cluster, only manual failover will work here.
And definitely in this case, because everything is coordinated manually, you can actually have a 2 nodes availability group because there is no need for quorum.
Thank you.
Okay, let's switch back and talk a little bit about a few additional read scale-out capabilities that we have with 2017. So to step back and look at a standard database workload, we have either OLTP, analytics, or reporting running on the database. Definitely, this can lead to many problems due to resource constraints, and it can create some bottlenecks. It will run, your OLTP workload can run into performance issues. Ideally, you would want to offload the read workloads to other systems, and for that, you can create a group of replicated databases, right, in order to offload the analytics or the reporting to these readable secondary replicas. So the client connections can connect directly to these secondary replicas, or you can take advantage of the read-only routing capabilities and connect to the primary, which will route the connections to the replicas that are part of the read-only, the pre-configured read-only routing list in a round-robin fashion for additional load balancing.
So, hey, Mehlet, so what's new in here in 2017?
Yeah, nothing is new. So
no, there is one thing new.
Definitely, this was available in 2016 as well. So when we added, the only thing that we added in 2016 from read scale-out capabilities perspective was the load balancing, right? But what we can do now with 2017 is to configure an availability group exclusively for read scale-out purposes without depending on a cluster, right? So if the goal is not to build a highly available system, you can actually create an availability group with cluster type none, as we showed earlier, and it will not, both on Windows and on Linux, right? So, and you will not need to have this overhead of managing a cluster from operational and from operational perspective.
Yes, so if your intention is just to scale out your read, you do not need to create a cluster. You can say cluster equal to none. You don't need to call your other part of your IT to set up a cluster that if you don't have access to it, it's quite easy to do it through T-SQL.
Yes?
The first 2 nodes actually in the cluster.
Mm-hmm.
The third node is in the other data center. Can you create a GC cluster?
No. So the cluster type is an availability group level property. So when you create availability group, that's when you define your cluster type, and all the replicas will inherit, if you want to say like this, will inherit that. So you cannot mix and match cluster types within your HA configuration. Another thing that I want to tell you, like, you cannot alter the cluster type either. So you cannot go from a cluster type none to an availability group, like just alter cluster type to external if you want. You will have to redo your availability group setup, because we imply certain things when you set up your cluster type, so we want to make sure from the beginning that it was set up with the purpose of an HA or a read scale configuration.
So was your question if you can have a node in a different data center and still have a cluster?
No,
absolutely.
If that is a cluster type none.
Like no, not for a cluster type none.
No.
Let's say
I think the question is if a third node can be of cluster type none,
okay.
which is not the case. We cannot. Mm-hmm. So when you add a node, you add it to an existing availability group, right? So that will have the type of
whatever the type it
yes.
has, it has to inherit that, right?
Yeah. So again, cluster type is an availability group property, not a replica property.
Can you add a database to the HA cluster as well as the read scale cluster?
You can.
Right now you can only add one database to one availability group.
No, what would you want to do when your availability group will fail over? Right, but so the answer is no, but I want to understand what would be the behavior, the expected behavior in that case when.
You have your failover cluster protecting your database, and then you have a read cluster providing that functionality somewhere else for your scale.
So one thing to clarify, you can still use readable secondary replicas and as well as read-only routing in a cluster as well. You don't have to set up a different system, but
right.
Yeah,
and you can also set up distributed AGs for that purposes.
Yeah, so I'm going to move forward to a different configuration, so you can scale even further your readable secondary replicas or your available readable secondary replicas by creating a distributed availability group, right? So we know that a standalone or a regular availability group will support up to 8 secondary replicas, right? But you can add additional secondary replicas and increase your scalability if you want by adding a secondary availability group with its own set of replicas. So from 8, you get to 17 if you do this, and you can scale even further if you want, if you daisy chain the availability groups, or if you create 2 availability groups from the same primary availability group. One thing I want to mention as a best practice, you would want to set up this as asynchronous, because you can run into a lot of performance issues if you will set up the secondary availability group, especially if it's in a different geographic area.
You want to worry about the latency of your commits.
But definitely, if you want to bring your data closer to the source of the read workloads, that's a configuration that you might want to have in mind. Oh yeah, so I was mentioning earlier that you can do read workloads from reporting and analytics perspective, but you can definitely use the readable secondary replicas for backups or for DBCC checks as well. So now let's move back to you, Murshad, and look at an example of how you can use read-only routing for read scale-out purposes. Again, with a cluster, in this case, we're going to use a cluster type?
None.
None, okay.
So let's look at the cluster. So this is my AG dashboard where I have 4 nodes set up in an availability group, and they're synchronized. Just wanted to point that out, that I don't know if you guys can see this right here. The cluster type is none.
Is this running on Windows or Linux?
It's running on Windows currently.
Okay.
Do you want me to turn it on to Linux in the background? No.
We should be able to do it on Linux as well. Definitely.
Yes. So it's a cluster type none. So I'm just spreading it out just so I can send my read workload to a different node. So let's look at how many nodes do I have as my read-only routing. So here you can see there is only 1 node. So WinAG node 0 is the primary, and the read-only server for that is WinAG node 1. So only 1 node that's connected right now. So let's run a tool that does some benchmarking. Basically, it throws a bunch of queries, and we can take a look at the transactions per second that is going on this server. So right off the bat.
What are you doing now?
I am adding connections. I'm adding about 40 connections that going to that read-only server. So it's all going to go end up in WinAG node 1, which is the read-only routing, only one node that's on the read-only routing list for this availability group. We're going to add more nodes as we go on, and we can see how many queries that we can throw at it. So let's add some more. At some point, your transaction per second throughput right here will plateau because it won't be able to keep up with the server. So what do you do in that case? You can add another server and add it to the routing list and scale up your workload. So let's quit this. Let's go back. We're going to add some more. And to do that, I have everything ready so that I don't have to remember how to write this. You don't want me to write this up here. It'll be here forever. So I'm adding one more node, WinAG node 2, to the availability group as a read-only routing list. To prove that out, let's run this query again. So now I have 2 read-only servers for this same cluster. Now let's go back to our SQL benchmark tool and run it.
So yeah, we use the server name. We connect to the primary with the read-only intent, right? That's how the read-only. Yes. Sorry. So one thing I want to mention about yes, this is a cluster type none. So you would say I don't need a listener because nobody will fail over. But read-only routing depends on the listener actually being created on the AG. So an AG has to be associated with the listener. You can create the listener with a primary IP address, for example, and that's how you're going to achieve.
And you would connect to the primary, but with an application intent read-only, which will route the query to your read-only replicas instead of going to the primary, so that you can still use your primary for write workload mainly, and use your other nodes as read-only queries.
Listen, yes, exactly. So pretty much that's why it's required, because the listener is it's going to do the route. In this case, the listener has the primary IP address, and yeah.
So I have a query here on a registered server that covers all 4 of the nodes, and if I run this, depending on what I capture, you can see some of the queries are going into node 2. I'll try to magnify this. Oh my God, the latency is super slow.
It's very slow, yes.
Yeah, and it doesn't even do what I want it to do. Sorry, guys. All right. So it's running at about 60 queries per second.
So this is already double than what we had, almost double.
Yes. And let's go back and add another one, my 3rd node. And to prove it out, I'm going to run this query again. So now I have 3 nodes. Yeah, okay. Now it works, now it behaves. 3 nodes as my read-only server. Let's go back and run this query, and we're going to crank it up a little more. It's basically connecting and running a bunch of queries. Yeah, a bunch of queries. You can see now it's running 85 transactions per second, whereas it was about, or actually it's even climbing up more than that. Before it was about 50-ish, or when I had 2, and about 35 when I had 1 read-only server. So let's go back, and let's see if I have any more connections here.
Yeah, definitely.
So I have WinAG node 3. I have some on node 2.
I guess depends when you're running it, you have.
Yeah, if I run it again, it's gonna, if it catches it at the right time. So there you go, some on node 1, some queries on node 2, and some queries on node 3. It basically round robins it. There you go, that was my demo. Thank you.
So moving further, these are a couple of other enhancements, as I was mentioning in the intro, that we had for 2017. The first one talks about support for DTC transactions when databases are part of the availability group. We started this scenario, supporting this scenario with 2016, but it had a pretty important gap there. So we supported in 2016 DTC transactions when databases, part of the transaction were in different SQL Server instances. Now with 2017, we closed this gap, so you can have DTC transaction with databases, part of the AGs within the same instance, and across databases that are part of AG and not part of this, or the combinations that you can think about, we do support with 2017. Another enhancements on the same topic is related to setting the DTC support flag. In 2016, you could do that only at create availability group time. Now you can actually run alter. So you can set the DTC support for an existing availability group. You don't have to recreate your setup. Another one is this require synchronous secondaries to commit. So for additional data protection and high availability, you can set how many secondary replicas are required to commit your transaction before committing on the primary. So this is a feature that a lot of our customers requested to ensure that they have an available failover target at all time. One thing I want to add and caution, if you want, is that in a 2 nodes plus witness, file share witness configuration, this is has a risk, right, associated with it, because if your secondary is offline, for example, for whatever reason, your primary will not be available, right, because primary will wait for the secondary to commit the transactions before committing on itself, right? So, I mean, it's up, but it will reject all the transaction. They will fail. So the only way to for this system to work, it's either you ensure that all the nodes are up, even a 2 nodes configuration, or you add an additional node, and then you're mitigating this risk a little bit.
That configuration is still not available right now. It's going to come with CE1, the witness only.
I was talking about the on Windows, for example, if you have a file share witness, not necessarily the witness on.
I completely missed that.
Any questions on these ones? No. So now we know that SQL Server had, in general, a strong partner ecosystem, and HADR is not an exception in this sense. This is just a snapshot of a resource page that we're trying to build for our customers to make it easier for them to find solutions that integrate with SQL Server. And we have here a few examples for backup, for example, for backup scenarios. We have DH2I and HP Enterprise, which offer a cluster support for Linux, for example. So Service Guard, you can use it to integrate with a Linux, with an availability group configured on Linux. So they provided the support.
So would that be in place of Pacemaker? You would use one of these?
Yes. So with this open design that we have with availability groups that you can create it, pre-created before you add it as a resource in the cluster, you have the flexibility to choose the cluster technology that you prefer based on whatever else you're using in your infrastructure, or based on availability SLAs or cost, and so on. So another solution that I would like to highlight here is Portworx, which they provide a highly reliable storage solution for containers, and that will ensure you will be able to configure a highly available system in a containerized environment, which is closer to a failover cluster instance. So it will provide instance level support. It's not for availability for availability groups like application level protection. We're gonna listen now another example of such solution that is available for our customers, and it integrates with SQL Server. This is a new service, Azure service, that is previewed here at Ignite. And it ties back to what we talked earlier about using availability groups and readable secondary capabilities for offloading backups. The workflow that they're gonna demo is using availability groups. And also it ties back to our partners that we're working with, building solutions that create this HADR system that we're talking about
Hela,
here.
does this only work on Azure, or will it also back up systems that are on premises?
You can back up any instances, irrespective
no matter where it is.
Yep.
Thank you.
Okay, now I'm just gonna try to see if I can make this play.
Go one more.
But before that, let me talk about a couple of traditional backup approaches that you folks might already be using. First one is a backup server approach, where you need to manage and deploy a complex backup. In this video, we'll talk about a new Azure backup feature to provide enterprise-class backup solution for your SQL servers running in Azure. But before that, let me talk about a couple of traditional backup approaches that you folks might already be using. First one is a backup server approach, where you need to manage and deploy a complex backup infrastructure comprising of your backup servers, storage, manage agent updates, etc. It is also expensive, as you need to deploy a heavyweight compute node in Azure. Second approach is to use SQL native APIs to back up either directly to cloud or locally. But there's no central management or monitoring, and you need to log into individual nodes for all your backup operations. It also does not provide you long-term retention, and you need to write complex scripts to manage recovery points. So we came up with a modern SQL backup approach for Azure, where you can just log into the Azure portal, select SQL servers and databases that you want to back up, specify the backup policy, that's it. No need to deploy any backup infrastructure. It is more cost efficient. You can centrally manage and monitor backups across different servers or even different workloads. You can also create backup policies based on your compliance and RPO needs. Moreover, it provides you log backup up to every 15 minutes with point-in-time restore. It supports availability groups and honor the AG backup preference. All this using SQL native APIs, so you get all the benefits of native backup. Let me show you a quick demo. I already logged into the Azure portal, and this is my recovery services vault, which is a central pane for managing and monitoring backups. Click on plus backup, select the workload that you want to backup. In this case, it will be SQL Server, and click on start discovery. You will get a list of all the VMs in your subscription. Select the VMs that you want to backup and click on discover DBs. I already have a few SQL servers discovered, so let me go to configure backup. I first need to select the databases that I want to backup. In this case, I have a SQL always on availability group, that is Shopcart AG, that I want to do backup. Next, I need to specify my backup policy, where I can specify the frequency and retention range for my backups. That's it. I just now need to enable backup for my databases. Let me now show you how simple it is to restore databases. Go to the list of protected items. Select the database that you want to restore. And click on Restore DB. You first need to specify the destination server where you want to restore the database to. Select a recovery point where you can specify a date and time up to a second. Azure Backup will use the appropriate full differential and log backups for recovery. That's it. Click on Restore. Since this is a small DB, restore should typically take a couple of minutes. Let me show you the restore job. I need to go to the vault, go to Jobs, Backup Job. So you can see that the restore job completed. Let me quickly check the server. As you can see, the database is restored. If you are interested in trying this feature, please send a mail to askazurebackupteam@microsoft.com and we will be happy to enroll you for limited preview starting next month.
Okay. So if you didn't already try SQL Server 2017, go ahead and download it. It's going to be available. The GA bits they're going to be available next Monday. And as I promised, I'm going to leave some time for Q&A.
So who here is really excited to go try out Linux, SQL Server on Linux today? Awesome.
Okay, awesome.
Is that a backup product supported for what versions of SQL running on Azure? Is it only for SQL 2017 or is it available for 2014, 2016, whatever we deploy on Azure?
It's not version independent. It's version agnostic, if you want, of the SQL Server database. Can you use the mic, please?
Yeah. Thank you.
We have another question in between.
In the meantime, we'll take another question while you go over the. Go ahead and line up, please.
There has been a backup already for SQL databases in Azure, but it only worked for full recovery model. Does this backup also support simple recovery model?
I would think so. So it should have. I would say yes. I'm not.
The backup solution, yes, it does.
Yes, yes.
For always-on availability group, you must have full recovery.
Sure.
You know
Yes.
that. Okay.
All right,
Yeah.
thanks.
You mentioned earlier on the service pack one, there will be an option with one server with a file share only option. Can you
No,
elaborate on
so-
that?
Not a file share only, no.
Oh, okay.
Yes, so it's not going to be a 2 replica plus a file share witness. It's going to be a configuration where you're going to have 3 replicas, but one of the replicas can be hosted by an express instance, for example.
Which is free, but you still need
Correct.
minimal hardware.
Yeah.
Install Express Edition and configure it as a configuration only. It doesn't move any data. It just has metadata in it, so it needs very little resources.
That's the case in Linux environment you're talking
Yes,
about, right?
correct.
Yes.
That's the only thing in Linux that's different from Windows today.
Yeah, so all your examples, I saw you using SQL authentication. Is your documentation, does it have all the documents necessary to like install the Kerberos packs on Linux and add the computers into the AD?
For the AD authentication, yes.
So-
Yes. One caveat I would add to that, the database mirroring endpoints do not support yet AD authentication.
Okay.
Right? We still use certificate-based authentication, but for standalone servers to connect using AD authentication, definitely our documentation has all the step-by-steps for even.
So you don't need to enable the SQL authentication at all on the instances?
To connect to the instances, no, you don't need to. You can do AD auth. But to set up an AG, which is what we talked about, you need to set up. We need to create a certificate and backup and restore the certificate.
The certificate, so.
Yes.
Yes.
I'll let him go. I have a bunch of questions.
Sure. So do the pacemaker constraints actually prohibit you from running a cross-subnet availability group on the Linux platform?
You can still configure across a multi-subnet configuration in pacemaker as well.
Okay, but what about the VIP that you showed that was tied to the cluster resource?
So yes, pacemaker has what we call if you want a dynamic property of the resource, so you can update the IP address depending on what node it will land on.
Okay, so cross-subnet is supported?
Yes.
No constraints there?
Yes.
Excellent.
Is the browser gone when it's on Linux? Do you always have to connect by port number?
For
Well, so you guys use 1433 in like government. We're not allowed to use that port, so we use a defined port.
You can configure the port using MS SQL conf tool.
Right.
Which, yes. You can.
But the browser, the browser's a lookup. If you want to connect my name instance and not explicitly give the port number, you can give server name / name. If you don't have a browser service, you have to connect by port number. Is there a browser Damien on Linux at all? Do you know? SQL browser.
SQL browser.
SQL browser is like
yes.
a lookup. It connect. If you connect by server name / instance name, it returns the client the port number, so you never have to know the port number.
I am not sure. Okay. I will have to follow up with you on that.
Yeah,
if you can
please,
yes.
Give us your email or something. We can follow up with that. We don't know that answer.
All right. For the Linux, you just said there's support multi-subnet, right?
Yeah.
Configuration. But how about the failover? The listener, do you need to assign 2 IPs because the subnet?
That's what I was saying earlier. You can configure the virtual IP with a dynamic, if you want, property of the IP itself. So when we configure the virtual IP, one of the properties of that resource is the IP. So you can configure it in such a way that it will change that property depending on what node it will land on.
So the pacemaker gave you the option?
Yes.
When the failover runs, go to different host.
When it lands there, the IP will be different.
Oh, perfect. Thank you.
It will still be a different IP, so you would like to have the client retry, right? Yeah, it will be a different IP, the same as in a multi-subnet.
You mentioned that minimal number of secondaries parameter. Can it be 0?
Yes, so 0 is the default in Windows, right, for backwards compatibility for reasons. On Linux, when you integrate it with the cluster, we actually set it for you. So
but you can change it.
You can definitely update it, but we think that's a better option to have it set for in behalf of the user just for external cluster type. On Windows, there are no changes there.
Thank you. There is a question over here. Let's go.
Yeah, I have a question about like in the demos, you click the availability groups quickly. Okay. But I know that you need to have endpoints and
yes. So the HADR endpoints, I didn't want to show you that part, but yes, you can. I set those up previously because I'm using a cert-based auth. I didn't want to show all that to you guys. I created a cert, imported it, and created the HADR endpoint right before that demo.
And what about the SQL Server service account that you need to add to all the SQL servers?
That was, I was mentioning earlier, on Linux, we don't yet support that configuration. It's only certificate-based authentication for the database mirroring endpoints.
Ah, okay.
That's something that we are still working on, yeah.
So,
That's one of the, SCOM supports SQL Server on Linux. We're still going through the validations of all the scenarios that we have on Windows as well to make sure that they work. So we're working with our partners to enable that.
So do you have any plans to make it available on Linux on Power, IBM Power?
Not that I know of, not at this time.
No, the 3 mainstream one we support is Ubuntu, SUSE, and Red Hat, obviously.
Yeah, so it's Red Hat and SUSE, but the hardware architecture is Power, not x86.
Yeah, so that's my answer still stays. Like at this time, I'm not aware of any plans in that direction.
To support. No. I mean, you can make it work, but it's not a supported configuration by Microsoft.
Yeah.
Right.
It works.
It works. No, I mean, it's not supported. So if you have an issue, we cannot help you, right? So Microsoft CSS will not help you if you have a EA contract, and if you have set it up on Oracle Linux, let's say.
Yeah, so you mentioned when you configure VIP, there's no like virtual server name and you're relying on DNS. How does, have you guys worked with loading SSL certificates with so typically, typical configuration with availability group with an SSL certificate is the primary entry is the node name, and then the alternative name is the virtual server name. And it's, you know, it's what the clients usually connect by virtual service name. Does that work, or you understand what I'm saying? You want to create like an SSL connection, encrypted TLS. You in Windows you install a certificate.
So
SSL.
TLS is supported in Linux.
Yeah,
yes.
but basically will the certificate load with an alternative name of the virtual server name? Like, so for example, if you have a client, right, your client's not going to connect by node 1, node 2, node 3. It's going to connect by your virtual server name. And in that, your virtual server name is usually listed in your SSL certificate.
So virtual server name, meaning the whatever name you
is mapped to DNS.
In the DNS.
Right.
Again, it's something that I'll have to get back to you on.
You know this.
I understand what you're saying. I don't know of any reason that should not work, but I'll have to double check.
I've had experience, like sometimes with just regular Windows, if the virtual server name is does not match the service name, the certificate won't load. So that's why I was just wondering.
I see. Do you mind if I give you my card, and we can follow up offline with all these questions? I would really like to address all your concerns.
Kind of continue with that. So again, let's go back to the multi-subnetting.
Yes.
Because you have the FQDN, this virtual server name, right, associated with the one IP. So when you fail over to a different subnet, the IP changed.
But you can
the
associate.
FQDN is dynamic, because right now in Windows it's dynamic. You have AD listener
again,
name.
whatever you have in Windows with a virtual network name, that capabilities does not exist in Linux. So what you will have to do is pretty much register in DNS the same name with
but
two
you
IPs.
have to, this is a manual, right? So when you
Yes,
fail over, you have to tell the
yes.
DNS server or DNS team to update this record to point to new IP.
No, but
in
you
Windows,
can register the same name with multiple IPs, right?
You cannot.
In a multi-subnetted cluster, like if you have a cluster that stretches to a different subnet, the SQL in Windows, the SQL Server, you have to have dynamic DNS. Where when the Windows service updates the DNS.
Right, automatically.
And yeah. So again, all that layer of functionality, there is no mapped features on pacemaker, right?
Yeah, you have to update that.
Add extra delays.
Yes. So the client takes care of doing that.
But I think there's this option in there. It's
yes,
like
so
register the active IP, I think, right? This is the one option. We always turn it on. So only register the active one. Right. But some of the clients have a problem with two IPs there. They will try.
With two IPs.
One of them is active, yeah.
They'll have a problem. They have to go loop through all the IPs, find out. Exactly. But some of the connections doesn't have the option. So we have one active IPs all the time, and the dynamic DNS fix that. Yeah.
And the concept SPN, is that done? You know, like
yeah.
you can't update because it's on the Active Directory account.
So that SPN work. So everything related to AD auth authentication on a
Right.
standalone server if you want. Works.
Yeah, it's all gone, right?
Yeah.
Okay, thanks.